another case here where that is applicable is the eBay case. For eBay, they are truly a global business, right? And I think today every business is really global if it's then the supply chain or if the market reach. And eBay is one of them. They are operating in many different countries, and they had one problem of localization of their websites. So traditionally, it has been very expensive to both translate pages, but also manage many parallel languages of pages. Also, eBay is such a dynamic marketplace where things has to be translated in real time. So that made a specific challenge here. And what they went out and did was to use the cognitive service within language to do the translation, but again customize it to their context and to their area of business, so that they got exactly that the right accuracy that they were looking for. Here in this case, they actually translated to 190 geographic location with this dynamic way of translating using the Azure Cognitive Services. So Henry, here at the end, can you dive a little bit more into the features within language, so the text analytics, and also show us a bit of the translator?
Thank you, Frederik. And we are back with another demo. But before we jump into the text analytics demo I have prepared, I just wanted to provide a little bit of context about what we're looking at. The services we'll take a look at are all dealing with languages. So specifically the translator and the text analytics service. The translator, you're probably familiar with what it does, because it's something that many of us use on a daily basis. But this is more than what you can just find in the Bing translator, for example. Here, you're also able to customize your translation. So for example, if you're working within engineering or let's say, for example, the medical field, there might be words that a normal translator wouldn't just pick up, wouldn't translate correctly. So here you have the ability to customize it as well. Also, there are additional features that you might not necessarily see in a normal standard translator, like for example, the dictionary. So finding other meanings for a word, or transliteration. So understanding how words that are written in another script would be pronounced by showing how they would be transliterated in Latin. So when working with other alphabets, Asian or perhaps Cyrillic languages, that could be really interesting as well. Then there's text analytics, and text analytics is a behemoth because we have a lot of very different services underneath text analytics, kind of just bundled them together. So part of text analytics are language detection, named entity recognition, sentiment analysis, and key phrase extraction. And these are all very different kind of NLP workloads that I just wanted to highlight. And I want to do so by just providing a brief overview of kind of what do we send in and what do we get out. So here I just put some exemplary JSON objects to show you how we also work with the API. Language detection is the first one I want to show, and this one is very straightforward. We provide some text and we get back a detected language with both the name, the ISO code, and the confidence. This will be useful later on because we will actually pass the language code to other services, like, for example, named entity recognition. Here, we provide a sentence like, our tour guide took us up the Space Needle during our trip to Seattle last week. And we'll get a number of identified entities. So, for example, the tour guide is a person, the Space Needle is a location, the trip is recognized as an event. Sentiment analysis is understanding the meaning based on the emotion within. Is it a positive or a negative sentiment? In our example test here, or our example text, the restaurant had great food and our waiter was friendly. We see that the sentiment is positive and we have high confidence on that individual sentiment. Key phrase extraction is all about getting the most important, the most meaningful words out of a sentence. You see here, we pass some text and we get the key phrases out. In this case, places, beautiful views, favorite trail, rest. I don't even need to read the sentence because you roughly know already what it's about because I just read you the key phrases. Now, that was kind of a rough overview over text analytics. But I want to, of course, not leave you without a demo. And this time we'll be demoing it in code. So I made a little Jupyter notebook that I just want to show you. So here we are in my little demo notebook. This is a Python notebook, a Jupyter notebook that is using the Text Analytics SDK. So we actually have a Python library specifically for interacting with text analytics. This makes it really easy for us because we don't actually need to use API calls over HTTP unless we want to. And we'll also see an example of that later on with the translator. With all of these code blocks here, I just wanted to highlight that 90% of the code you'll see in here is actually all just for printing it pretty. With sentiment analysis, which is the first one that I wanted to show off here, we really only do 2 lines of code here. In the first line that really matters, we are specifying our what's called documents. In our case, our documents is just an array with 1 single sentence in it. Or rather, actually, it's 2 sentences, but it's 1 single string. Here we're passing the sentence, I had the best day of my life, and I wish you were there with me, just as 1 string to the documents array. That we are including in this call here to client.analyze sentiment, and we're just passing the documents. You will note that the client object here is just a text analytics client I previously got from authenticating with the service. If we run this little code block, you will notice, here we go, immediately we get a result. We get positive sentiment on I had the best day of my life and somewhat neutral sentiment on I wish you were there with me. I think that makes sense. The slightly more advanced version of sentiment analysis is looking at the individual words and which meaning they carry. So this is called opinion mining, and we can do that too in sentiment analysis. Here we have a slightly different sentence that we're using as our document. It says the food and the service were unacceptable, but the concierge were nice. And you will see once again, we essentially just do this 1-line API call. We go client.analyze sentiment. We pass it the documents just like before, but we're setting the show opinion mining parameter to true. This will allow us to get a lot more detail on the individual words. And if I run this, once again, all the remaining code is just for printing it nice so that, that it looks good for you. You will see here, we have identified a number of word pairings here. For example, food was the target of a negative sentiment. And that was because the word unacceptable was assessed to carry that negative sentiment. Similar for the service here. The service was also considered unacceptable. So this one is also negative. The concierge, it said the concierge was nice. So here we can actually see the concierge was the target of positive sentiment through the word nice. This is a really powerful way to, for example, analyze product reviews and figure out what do people like, what do people not like, rather than just looking at the entire sentence as a whole and see whether that is positive or negative. Language detection is very straightforward. So I'm just going to execute this code here. You'll see what we do. Once again, we define a document and then we go client.detect languages and pass the document. You will see here for this sentence that I don't dare to pronounce, it says the language is French. You will note that we are able to specify a country hint over here. And this allows us to give the model a little hint to narrow down what context we're working in. If, for example, we provide so little context that multiple languages could be an option. In this case, if we say country hint United States, the model is more likely to gravitate towards languages that are used in that locale. Entity recognition is similarly straightforward. Once again, we define our documents. In this case, we say, I had a wonderful trip to Seattle last week. And we call client.recognize entities in order to get our result. You see, we found a number of named entities. Seattle was recognized as a location. And last week was recognized as a date range. This is particularly interesting because not only do we identify week as a unit of time, but we specifically identify last week. So this also shows that named entities can extend beyond a single word alone. A particularly interesting version of named entity recognition is personally identifiable information recognition. This way we can use cognitive services to pick out parts of information that might be sensitive. So let me just run this here. As documents, we're passing two sentences this time. We're passing the employee's social security number is a bunch of numbers, and the employee's phone number is with their phone number. You will see here that we use client.recognize PII entities, and we pass the document and the language code. And once again, the rest just for printing. What we get back is, or redact the text here, this we did down the printing code. But you will see we get the category of the entity we identified and the value of that entity. So for example, in our application, we could now say if it's a social security number, we want to redact the information or maybe just flag it. On the other hand, if it's a phone number, maybe it's okay to go through, or we maybe just take out half of it or something along those lines. We can customize that in the business logic in the end. So this is PII detection as well. Key phrase extraction, I already mentioned it as well. And here we have another sentence once again. My cat might need to see a veterinarian is the sentence. And I'm glad I managed to nail the pronunciation of yes, see, I can't do it a second time. So let's run the cell here, and we'll see that the key phrases are cat and veterinarian. That is pretty accurate given the sentence. We're using client.extract key phrases in order to get this functionality. Those were most, even if not all, of the different abilities to use the text analytics cognitive service. But we also we also talked about the translator. So let's take a quick look here at the translator. And with the translator, we'll show a slightly different approach and call the REST API over HTTP to show you that this is also how you can interact, not just from Python, of course, but from many, many other languages. We are involving a few more lines of code this time just to get the subscription key. I have it here stored in my key vault to set up the endpoint of my translator instance and define some of the headers here. But the important part happens down here. We're defining the body that includes the text element here. In this case, I say, hello world. This is my first message transmitted in multiple languages like Spanish and Danish. And you will notice that here in the parameters that we're attaching to the end of the URL, we're actually defining both Danish and Spanish as the target languages. Now we are getting our results here by just performing a standard post request to that URL that we're constructing. And what we'll get out, you'll see in a minute. Here we go. We're getting the original that we passed, but we're also seeing the translation both in Danish and in Spanish. And you could, do this with multiple languages, with many other languages, either at once or one after the other. This was my little demo regarding how to work with text in cognitive services. And now we'll hand it over to Frederik for our wrap-up.